Hello dear students, in the previous class I asked you to solve some of the questions. So today we will discuss the solution of those questions and we will proceed the next topic. So in the previous class I asked you to solve 5 questions. I hope you must have tried to solve those questions. So the first question was distinguish between speed and velocity. So here is the answer. Speed and velocity. Speed is distance traveled per unit time. Velocity is distance traveled per unit time in a given direction. See, velocity is displacement travel per unit time. But here I have used the word distance because here I have mentioned in a given direction. Distance in a given direction itself is known as a displacement. So here you can also write a displacement traveled per unit time. Now speed is a scalar quantity. Velocity, it's a vector quantity. Speed cannot be 0. Velocity can be 0. So this is the answer of the first question. Now the second question, under what condition or conditions is the magnitude of average velocity of an object equal to its average speed? So here is the answer of the second question, that is when the body moves in a straight line. So when the body moves in a straight line, this is the answer. Now the third question, what does the odometer of an automobile measures? Odometer measures the distance traveled by the body or by the automobile. Now the next question, what does the path of an object look like when it is in uniform motion? Now, if an object is moving in an uniform motion, what does its path look like? So, the path of an object looks like line. It may be a straight line, zigzag line, and curve, etc. So, it may be a straight line, it may be a zigzag line, it may be a curve path. Okay. So here you are talking about uniform motion. So as I explained, uniform motion is the motion where the body covers equal distance in equal interval of time. Now the equal distance may be a straight line, may be a zigzag line, may be a curve path having the same time. So it can be a straight line, zigzag line, or a curve path. So the next question, during an experiment, a signal from a spaceship reached the ground station in 5 minutes. What was the distance of the spaceship from the ground station? The signal travels at a speed of light, that is 3 into 10 to the power 8 meter per second. So this is a problematic question. Here we are going to solve it. Now suppose this is the earth and here this is the point which receives the sound, okay, or receives the signal. Now here is the spaceship. Now from the spaceship it takes 5 minutes, that is 300 seconds to reach the sound. The speed of light is 3 into 10 to the power 8 meter per second as it is given. Now here you know that speed is equal to distance divided by time. So here in this question it is asked you to calculate the distance. So distance will be equal to speed multiplied by time. So speed is given 3 into 10 to the power 8. Time is given 300 seconds. So if you multiply this one, it will be 9 into 10 to the power 10 meter, which equals to 9 into 10 to the power 7 kilometer. So this is the final answer. Okay. Now these are the solutions of this question that I have asked in the previous class. Now we will continue the chapter from rate of change of velocity. This is very important. Rate of change of velocity, which is also known as acceleration. So far we have completed distance, displacement, speed, velocity. The next term we are going to deal with the rate of change of velocity, that is known as acceleration. So in these previous classes we talk about uniform motion and non-uniform motion. So here it tells that during uniform motion of an object along a straight line, the velocity remains constant with time. So what it is trying to tell you, that if a body is moving in a straight line, having uniform motion in a straight line, then its velocity remains constant. Okay, because what is uniform motion in a straight line? Equal in distance traveled within equal interval of time. So velocity remains constant. If velocity remains constant, then what is the rate of change of velocity? See, what is change of velocity? Change of velocity means difference between two velocity. Rate of change means the difference between two velocity within a particular interval of time. Okay, so here in this case the change in velocity of an object for any time interval is 0. So let me explain this one. Now suppose this is a path in which a body is moving. The body has started its motion from point A. It will reach to point B. Again it will reach to point C. Now from A to B the displacement is suppose 1 kilometer. From B to C the displacement is also 1 kilometer. Now to travel this much displacement 1 kilometer, suppose the body will take 1 minute from A to B and B to C also 1 minute. So the velocity remains same, that is 1 kilometer divided by 1 minute here. Here also 1 kilometer divided by 1 minute. So the rate of change of velocity means, what is the change of velocity? 1 kilometer minus 1 kilometer. Okay, difference between two velocity. The rate of change of velocity is equal to difference between these two velocity divided by time. So if in numerator, that is change of velocity, becomes 0, 0 divided by anything which is present in the denominator equals to 0. So in this case, for any time interval is 0. However, in non-uniform motion velocity varies with time. So in non-uniform motion the velocity of the body varies with time. So if velocity varies, the numerator, that is the difference between the velocity, will not be equal to 0. It has different value at different instant and different points of the path. Thus the change in velocity of the object during any time interval is not 0. So in case of uniform motion the rate of change of velocity becomes 0. In case of non-uniform motion, the rate of change of velocity is not equal to 0. Okay. So far we have completed this one. Now we'll continue. Now see, here is a question. Can we now express the change in velocity of an object? See, as we know that here we talk about the change in velocity in case of uniform motion and non-uniform motion. Now, is there any particular word in which we can denote the change in velocity of the object? So here comes acceleration. Acceleration is the change in velocity of an object per unit time. In 1 unit time, that is in 1 second, how much velocity is being changed? Like suppose you throw a ball in the upward direction. So you might have noticed that the ball starts moving in the upward direction and finally it comes back to you. Okay. So when the ball starts move in the upward direction, at certain point its velocity becomes 0. Again from that particular point it will come back to you. So suppose when you throw the ball in the upward direction, its velocity is 10 meter per second. So gradually the velocity of the ball will keep on decreasing and it will become 0. So here, if you randomly take 2 points, then suppose at this point the velocity of the ball is 10 meter per second. Then at point B the velocity is 5 meter per second. Okay, so acceleration. What is acceleration? From first point to the second point, what is the change in velocity divided by the time which is taken by the body to cover that much distance? So that is known as acceleration. Okay, now if you have any doubt, you can ask me. Okay, so you can comment your doubt. Now we'll continue this one. If the velocity of an object changes from initial value u, here we consider the initial velocity of the body as u to the final value v. So here suppose we consider the initial velocity of the body as u and the final velocity of the body as v. So from initial velocity u to final velocity v, the body will take certain time. Suppose that time is t. So acceleration. What is acceleration? As you know that acceleration is nothing but the change in velocity divided by time. So here see, there is some printing mistake. It should be t. Here a is written. So please make this correction. Okay, so acceleration here it should be small a. So there are some mistakes. So please correct this one. Small a acceleration equal to v minus u divided by t. Okay. This kind of motion is known as accelerated motion. What is accelerated motion? So when the body moves, its velocity changes. Velocity changes means it might be increasing, it might be decreasing. So this kind of motion is known as accelerated motion. In case of accelerated motion, the velocity of the body keep on increasing. In case of decelerated motion, that is retarded motion, the velocity of the body keep on decreasing. For example, if you apply brake, the speed of the vehicle keep on decreasing and it will become zero. Okay, finally. So that is called retarded or decelerated motion. We'll talk about retarded motion later on. Now, the acceleration is taken to be positive if it is in the direction of velocity and negative if it is opposite to the direction of velocity. That means, as you know that velocity is a vector quantity, it has a particular direction. If the direction of acceleration is also a vector quantity. If the direction of acceleration and the direction of velocity is same, then acceleration is taken as positive. Now suppose this is a body. Now this body is moving in this direction. So this is the direction of the velocity. If the direction of acceleration is also same as the direction of velocity, then the acceleration is taken as positive. That means here the speed of the body is increasing or the velocity of the body is increasing. If the acceleration of the body, that is if the direction of acceleration of the body is not same as the direction of velocity, that is if the direction of acceleration of the body is opposite to the direction of acceleration of the body, here acceleration is considered as negative. As I was talking about retarded motion, this negative acceleration is also known as retarded or decelerated motion. Now the SI unit of acceleration is meter per second square. This is the symbol of power. Meter divided by second square. So see here, do not get confused between the SI unit of velocity and acceleration. The SI unit of speed is meter divided by second. The SI unit of velocity is meter per second or meter divided by second. But in case of acceleration, it becomes meter divided by second square. Now, if an object travels in a straight line and its velocity increases or decreases by equal amount in equal interval of time. See here, earlier we were talking about equal interval of distance or equal interval of displacement with equal interval of time in case of which motion? In case of uniform motion. So if it is in case of uniform motion, we consider equal interval of distance or displacement with equal interval of time. Here we are talking about acceleration. So acceleration is equal to change in velocity divided by change in time. That is, in general, acceleration equal to velocity by time. So here we will consider change in velocity by change in time. So if an object travels in a straight line and its velocity increases or decreases by equal interval, by equal amounts in equal interval of time. Okay. then the acceleration of the body is said to be uniform. As when acceleration is said to be uniform, when the change in velocity and change in time is equal. When the motion of the body is said to be uniform, when the distance traveled by the body with respect to time is same. Okay, so remember this one. The motion of a freely falling body is an example of uniformly accelerated motion. As you know that the acceleration of gravity of the earth is 9.8 meter per second square. It is a constant. Okay, you cannot change its value. Okay. So wherever this body will go, about the freely falling body will cover in the coming classes. There is a total chapter related to this freely falling body. Freely falling body, for example, suppose you hold something in your hand. Suppose you hold your pen in your hand and just let it go. That means you are not applying any force, you are not pushing the pen, you are not throwing the pen in a downward direction. You are just leaving it and it will fall down. That is called freely falling body. Okay. So this is an example of accelerated motion. Okay. Now, on the other hand, an object can travel with non-uniform acceleration if its velocity changes at a non-uniform rate. Okay, so what is uniform acceleration? That change in velocity and change in time is constant. Okay, what is non-uniform acceleration? Change in velocity divided by change in time is not constant. If I want to give you an example, suppose at point A the velocity of the body is 5 meter per second. At point B the velocity of the body is 10 meter per second. At point C the velocity of the body is 15 meter per second. From point A, as we have considered this one as initial point, we take here suppose time equal to 0. At point B time is equal to 5 seconds. At point C time is equal to 10 seconds. Okay, that means the body will start its motion from point A. After 5 seconds it will reach point B. Again after 5 seconds it will reach point C. Okay, so here what is the acceleration here? So we can calculate here that the change in velocity here between any two consecutive point, 10 minus 5, here it is 10 minus 5 is 5 divided by this 5 is 1. Here 5 minus 0 is 5 divided by this 5, that is 1. So it becomes constant. That is called uniformly accelerated motion. In case of non-uniformly accelerated motion, if we take these values, like suppose this one is 5 meter per second, this is 10 meter per second, this is 13 meter per second. So 13 minus 10 is 3 divided by 5. 10 minus 5 is 5 divided by 5, that is 1. So these are not same. Okay, so in this case these are considered as a non-uniform motion or non-uniform acceleration. Okay, now it is non-uniform acceleration. Now there is an example. Starting from a stationary position, Rahul pedals his bicycle to attain velocity of 6 meter per second in 30 seconds. Then he applies brakes such that the velocity of the bicycle comes down to 4 meter per second in the next 5 seconds. Calculate the acceleration of the bicycle in both the cases. That means there is a boy named Rahul. He was pedaling a bicycle with a speed of 6 meter per second. He continued pedal it for 30 seconds. Then he applies brake. If you apply brake, what happens? The velocity reduces. So earlier the velocity was 6 meter per second. Now it reduces to 4 meter per second. Now from 6 meter per second to 4 meter per second, it needs some time. That time is 5 seconds. Now calculate the acceleration of the bike in both the cases. Okay, so here the solution is given to you. Try to understand this solution on your own. Then here there are some questions. I have given you 3 questions. Try to solve these questions. Okay. In my next video, I'll explain this example along with these questions. So before that one, you try to understand the question. and try to solve these 3 questions on your own. Okay, if you have any doubt, comment me on the channel. I'll be clearing your doubt as soon as it is possible. Okay, so any kind of doubt you can ask me. Thank you and have a nice day.